Hello everybody, day 224, 225. Yeah, let's get into it. Another video of our right now I'm working on the HTTP, building an HTTP server from scratch. Well, not really from scratch because he's teaching me how to do it, so it's more Go practice, so that's really fun. Unfortunately, parsing code tends to be just one edge case after another. Remember how I said TCP guarantees to be order? That's true, but I never said it had to be complete. TCP and by extension, HTTP is a streaming protocol, which means we receive data in chunks and should be able to parse it as it comes in. So instead of a full HTTP request, we might get the first characters like this. Okay, first let me even just like this. We're in a good state right now, so I need to commish dash a dash m added basic parsing logic. Fortunately, parsing code tends to be so instead of full H, we might just get a few characters like this. We need to manage the state of our parser to handle incomplete reads. For example, maybe the first pass we get GE. It needs to be smart enough to know that it's not done yet and keep reading until it gets the full request line, right? Okay, chunk reader. Alright, let's do this. We paste this in your request.test file, right? So we got request.test. Okay. Reads up to len of p or num bytes per from the string per call. It's useful for simulating reading a variable number of bytes per chunk from a network connection. Let me import IO as well. Why? Wow. By using min. Modernized. So do they want me to do end index is equal min of end index or a length of cr.data? So this is what they want. Okay, that's nice. Okay, so let me see what this really does. So what it does is, so we have this chunk reader, which is data, num bytes per read, and position. So reads up to length of p, or num bytes per read, bytes from the string per call. It's used for simulating reading a variable of bytes per chunk from a network connection. Okay. Update your test suite to use the chunk reader and test for different types of bytes per chunk. Okay. Okay, so let's do this. Okay, this is kind of annoying. Let me reset real quick. So, okay. So I have this now. I don't need. For now, I'm getting rid of all these. Um, um, test good get request line. Good get request line path. With path. Okay, let's do another test case. Let's do another one. Good get. It was like a failed. Bad. Crest. Let's say it's out of order, right? Let's just say we don't even have that. Require dot. I forgot how I forgot how we did that. Let me see this one. This one right here. Copy. Wait, let me. Okay, wait, hold on. Okay, so it seems like it doesn't matter. So I'm gonna just do it like a bunch of ones. Let's do like 1 3 1. Wait. Let's do like 4 5. Bytes per read. Okay, I messed up too. This needs to be the same though. Let's do like 10. Wait, how many? I don't know. Length of. Let's do. I don't know how high we can go. Like, data, I guess. I mean, I could, but. Can you even do this? Let's do 9 or something. Get. Okay, so slash coffee. Okay, so we have a bunch of test cases. P.data. Oh. Yeah. Reads up to. So I can do. I'm going to do the highest one here. Let's do the entire string. Oh, -1. Okay, now a request from reader, right? It's gonna be a little weird though, cause it actually didn't break. Wait, what? It's probably gonna fail, cause my logic isn't, you know, isn't. I need to kind of refact. Wait, hold on. I want to see the solution from this one, cause I know my other one wasn't the best. So request.go. Let's see what they did. Okay. Interesting. Let's do this instead. I think this is a better logic. Because it is interesting why my also include bytes. We also have constant variable const crlf, which is this, right? We don't need errors, I guess. No slices, no strings. So get the index. So bytes.index. I'm curious what this does, right? So we okay. Okay, never mind. Returns the index of the first instance of separator in S, or -1 if separator is not in. Oh my god. Okay, that's so nice. Right? Oh, I gotta have FMTA, of course. T. Request line from string. That's an interesting one. Request. Oh shit. Okay, it's a new function. Copy. right? Okay, so we do need strings. Strings. What else do we need? Okay, nice. Okay, so what do they have? So what do they do here? So they got the index bytes.index data. If we can't find the first instance of it, right? Then take the up to, so 0 up to that. Then the request line is equal to request line from string, which is it takes in a string, right? Part splits it by the space. If that doesn't poorly formatted, right? Then we method parts. Okay. And then we return this request line method version parts. Okay, so now we need to restructure this. So that we need to restructure this so that it takes in it takes in it takes in it takes in like it will keep going even if you don't find it, right? So okay, be sure, yeah. Update your parse requirement to return the number of bytes it consumed. If you can't find it, it should return 0 and no error. Okay. Return the number of bytes it consumed. What does that mean? Okay, if you can't find it, return 0 and okay, and then instead of returning a request line, we're gonna return integer, and we'll do I guess error. Let me cook, guys. Let me cook. So this one. Right. Update your parse request line to return the number of bytes it can. Okay, yeah. Okay. Da 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 da. Okay, I'm kind of confused. Update it so that it includes like a new thing instead. New internal enum. I just use to your request struct to track the state of the parser. For example, you just need two states: initialize or done. Implement a new function called R method. It accepts the next slice of bytes that needs to be parsed in the it updates the state of the parser and the parse request line. It returns the number of bytes it consumed, meaning it successfully parsed, and an error if it encountered one. This one's really hard. It should to continually read from the reader. and parse chunks using the parse method. The loop should continue until the parser is in the done state. You need to keep track of a buffer to read into data. I started with the size A and grew it as it needed. I shifted the data in and out so it doesn't need to keep I don't need to keep storing already parsed data. How many bytes you've read from the reader, how many bytes you've parsed from the buffer, the end result. If the state of the parser is initialized, you should call it parse request line. If there's an error, it should return an error. If bytes are parsed, okay, this is getting way too much work. Be sure to test your values as low as 1 to high. Okay, whatever, yeah. Update your parse request line to return the number of bytes you can. If you can't find it, it should return 0 and no error. This means, okay, to return the number of bytes it consumed. Okay. Instead, can I even return 0, bro? That's the problem. Add a new internal enum. Enum in structs. How do you even do that? That's false. I'm pretty sure you can. Update your parser request line to return the number of bytes it consumed. If you can't find this, it should return 0 and no error. This just means that it needs more data before it can parse your request line. Add a new internal enum. Okay, in your request. I guess state or something. I guess we can say. I guess we can do int. Or Okay, I don't really mind having a whole string. Implement a new function. Okay, we'll do that. Func, I guess R, request. Well, let me make some methods specific to this. So let's do this. Func, R, request. Let's see, parse. I guess parse, yeah. Take some data, byte. Let's return. Turns in int and error. Oh, okay. Okay, hold on. It updates the state of the parser and the parsed request line. It returns the number of bytes is consumed, meaning successfully parsed, and an error if it encountered one. It accepts the next slice of bytes that need to be parsed into request struct. It updates the state of the parser and the parsed request line field. It returns the number of bytes it consumed, meaning successfully parsed, and an error if it encountered one. That's my problem. Why are we okay? Shouldn't we like what do you mean by parse? Meaning like we like actually do this like do this part right here, right? Like request line from string. Like is that like call this? Because I rather call this once we have all the data. And I'll know when that data is when once we hit the request line, which is this, right? Parse request line. If it can't find more, add a new internal enum to your request struct to track the state of the parser. For now, you need two states: initialize and done. Implement a new function method. Update the parse request line to return the number of bytes it consumed. If it can't find this is important, it should return 0 and no. This means that it needs more data before it can parse the request line. Add a new internal enum to your request struct to track the state of the parser. What is this? Internal enum in Go. It returns the number of bytes it consumed. Okay, how about this? So I guess one more thing, I guess. Let's do this. Int, right? This one obviously will be 0. Here we'll say also 0. Yeah, I guess 0 because it failed. Here it's gonna be length of data from IDX, right? Happy now. So that just tells us additional information, right? Now, whoever uses this function, now it's broken. Okay, I actually did this badly. I want error to be at the end, because it's cleaner that way. Oh god. Error. Right? So we put... Oh my god, what is happening? So, do this here. Happy. So, we get the request line object. It could be no. Or... and bytes consumed. Right? It's not used yet. So what do I do with this? Why is this important? Return. It's if it can't find this, it should return 0 and no error, and that's true. We're not gonna return. Oh shit! Let's do that. No. Yeah, let's do that. Perfect. So it'll bypass this if statement here. Now we'll know how many bytes consumed. So basically, okay. Add an internal state. Okay, so let's say to keep track of the state of the parser, you need two states: initialized or done. Okay. Accepts the next slice of bytes that need to be parsed into request. It updates the state of the parser. It updates the state of the parser and the parse request field. Updates the state of the parser and the parse request line field. Returns the number of bytes consumed, meaning successfully parsed, and an error if it counted one. That need to be parsed into request struct. I really don't like that because, like, I wanted to only parse once we have a whole set of string. That's weird, man. Like, I have to be parsing it like while I go. Reading all bytes. Request from reader. Okay. Read line from... Wait, what? This is fine. It's just this one here. Okay, instead of reading all the bytes and then parsing the request line, it should use a loop to continue read from the reader and parse new chunks into parse method. The loop should continue the parser until the parser state is done. You need to keep track of buffer. I started with size A and grew as I needed. So we have bytes consumed here. Also, I think I meant this wrong. Let's do okay, type state. Wait, let's do this. Yes, let's do this. State. State. Be sure to test all. Okay, update your parse requirements. Yeah, whatever. So state parser state in, right? And then we have the go struct thing. We'll do this like this. The first value will be initial okay, initial state parser state iota, and then then done state. Yeah, there you go. So that's, and then the state here, it's gonna be parser state. Yeah. Okay. Now we can move along. Okay, so I think I'm gonna do it like this because I still don't understand. I don't know if it's trying to tell me to, as you go, like, oh, as soon as you get, put it in the request struct field. But I think it makes more sense to, as we go, we keep building out, I guess, the buffer in this case. We keep building until we hit, until we finish the request line. Then parse, meaning when I say parse, then what is it? Request line from string. Yeah, that part. That means we have enough information to do. Because I was like, that's like a crazy problem to like. Because how do I know if I'm gonna be like, let's say it's the letter F instead of a T, and then that's just like, that's insanity. So I think it makes more sense. So we wait until we hit CRLF, whatever that CRLF. So let me first break this down. I'm gonna do one more thing and then call it a day. So I can. This was kind of hard. This project is pretty hard, not gonna lie. Even with all the help here. Be sure to test all of it. Okay, parse lines to return the number of bytes. If you can't find more data, should return a no error. This means they just need more data. Okay, that's the information we have. So first, let's do for true, basically. Right? Hold on, just for, I guess, let's create buffer, right? Make less size of, I guess, bytes, size of 8, right? Right. While the buffer dot length, okay, well, that's so JavaScript. While buffer len of buffer -1 does not equal CRLF, right? Okay, I can't use it. Are you serious? Okay, that's true. It's a string. So let me convert this to a string. Right? So, right? So, I guess let's do this. I'm gonna have a Boolean running to true, right? And running, right? For running, if bytes consumed equals to 0. Okay, if it does not equal 0, because I'm gonna assume always the case, right? So if bytes consumed does not equal 0, then we have reached the, means we've consumed a good amount. Like we've consumed an amount that is worth, right? That means we're done. So we can say running. Okay, not true. Like let's say we only consumed this much, right? Damn. Okay, hold on. This is fucking hard. Let's do instead. Let's do buffer. Let's do this. String of buffer of length of buffer does not equal CRLF. So as long as the last thing. Damn. Also, I can't even guarantee this. How do I know when to stop? Okay. That's why I don't know. So I'm going to always say for true. I don't know. I won't know when I need to stop. But I know when to stop. Right? So parse request line is going to give us how much it's consumed. Right? If bytes consumed is greater than 0, right? Then request line, oh my god, no. That's good, right? That's good. I'm kind of confused. If it's 0, I'm kind of confused. Yeah. So reading all bytes, then parsing the request line. It should use a for loop to continue read from the reader, parse new chunks using the parse. Okay, that is true. Let me see what this parse thing does. Implemented this. It accepts the next slice of bytes that need to be parsed from into the request struct. It updates the state of the parser and the and the parsed request line field. It returns the number of bytes it consumed, meaning successfully parsed. Oh, okay. Okay. Oh, makes sense. I'm getting confused here. The number of bytes consumed is always going to be at least this much, right? You know, so I think that's fine then. I think we can do this. Length of buffer. String length of buffer oops, okay, hold on, because I'll eventually hit the point, right? Buffer okay, if the length of buffer, so string buffer or length of buffer -1 equal CRLF, right? Then, so that means we're not done with that request line, so we continue, right? Then we break, right? Because we consumed. I'm confused. Okay, now I need to go here. Okay. I think this is a bad condition. Let's do this. R dot state. Spelled this wrong. Initial state. Let's do this. Done state does not equal done state. Yeah. I mean, we should do a request. Actually, we should create this instead. R. Okay. What's wrong with this? Okay, it's just not used. Okay, so then we'll we need to make this thing. So it's gonna take a stream of bytes that we've consumed, right? And going to check a few things. Basically, just check. Convert this. Okay. I still don't get what this parse thing does. Accepts the next slice of bytes that need to be parsed in the request struct. Oh, okay. Okay, so basically, okay, so we'll do a switch statement, right? And we'll do this. Switch, I guess, request line data, and we'll convert it to a string, right? Request line. Okay, so basically if request line, I guess strings dot contains, right, crlf, then we're done with that line, so we can return length of data and no error, right? Or we can return nothing and no error. Hold on. And then hold on, we have to update the state. R dot state equals done state, right? How about that? Okay, so now oh, if it does contain it, okay, then done. Okay, we'll do that at the end. Then we'll call we'll call request from this one, right? Right? Request line, right? Which will give me an object, right? Alright, guys, I think I need to take a break. I'm kind of stuck. I'll try to figure out more tomorrow, but I think we're getting up in about an hour. But anyways, thanks for watching, guys. I'll see you tomorrow. Peace.